Just let me know if you guys can hear me, okay? Like, I don't know. I'll give it a. Let me check, okay? Let's see, it's still waiting for me. But anyways, I think I'm live. I don't know what's wrong with this. Just in case if anyone has joined, just let me like ping me on the chat, okay? Like, yeah, I can hear you, something like this. Okay. Okay. So the video has started, right? Too many ads, I guess. So like I'll just check it like whether is the audio clear, man. Just I guess the audio is clear, right? Okay, yeah, the audio is clear. So I'll pause this video, I'll like mute it, I'll make it go live. Okay, so let's get in the solutions. Okay, so let's get in the solutions. So basically today's contest there were 4 problems. That is, the first one was final array state after k multiplication operations, and the second one was count almost equal pairs, and the last 2 problems were a modified version, or rather we can say that it was an advanced version of that. Okay, so let's get on the first question. So I'll divide this video into 2 parts. Okay, I'll divide this video into 2 parts, where the first part I will be explaining A and C together, and the second part I will be explaining B and D together, because since it's a advanced kind of thing, so I don't think that I would be needing to explain the whole thing in very details. Okay, like I won't go with the simpler approaches, I will go directly with the complex approaches. Okay, I hope this is right. Okay, so let's get in the video. So the question, so I'll be going to C directly. The question, you can see that it has been stated that you're given an array nums, an integer k and an integer multiplier. So what basically you have to do is, like you have to, for every operation, so you have to perform k operations beforehand. It is given that you have to perform k operations on nums, and in every operation you have to choose the minimum value of x, which is in nums, and you have to multiply it with multiplier. Okay, clear? Now, sorry. So and okay, so another thing, that is you can apply modulo 10 to the power 9 plus 7, which is a prime number. You obviously know, people who are related to CP knows how this works. So a basic approach, okay, just don't look at the code right now, I will be explaining the code later on. So basic approach how to do this. So this is very similar to a problem which occurred on Code Chef. I think the last Code Chef contest, some similar type of problem occurred. Okay, so over there the question was a little bit easier, you can say. The question was that you have to multiply it with 2 instead of a specific multiplier given. So basically the difference is that you have to use that exponential mod thing. Okay, otherwise apart from that the question is same. Okay, so let's say you have, okay, we'll take this example. Okay, 2 1 3 5 6. Clear? So let's say we have 2 1 3 5 and 6. Okay, okay, so let's say we have 2 1 3 5 6, and over here you have to multiply it with a multiplier. So what was the multiplier? The multiplier was 2, right? And you have to perform 5 operations. So if we go directly, simply, if we are going to go for the brute force for now. Okay, so let's say we are going for the brute force. So what we are going to do is, we are going to find the minimum, that is 1, and multiply it with the multiplier. What was the multiplier? The multiplier was 2. Okay, so let me write it. Multiplier is 2 and the number of operations, it is 5, right? So first we can choose this and make it 2. Okay. Now what is the minimum element? Now remember one thing, it was given in the question that if you have encountered a minimum element and there are various positions of that minimum element, so you have to take the element which occurs at the beginning, at the first, I mean whichever occurs first. So over here this is this position, this thing, okay. So we have to multiply this with 2 again, like 2 now, okay. So it becomes 4. Now you can see that the minimum element now is this 2, okay, this 2. So we can make it, so now we can make it 4, okay. Now we can make it 4. Clear? Then we are having operations we have to again perform. So that is this. So this becomes 6 and this becomes 4 2s are 8, right? I think we are done with all the operations. So finally the output is 8 4 6 5 6. So you can check it like, okay, sorry. So you can check it that it is, let me delete this window, okay, otherwise it will be. So you can see that it is coming out to be 8 4 6 5 6, right? So I hope this is clear, like what is a brute force approach. Now there is an approach which you may think is a little bit better approach, that is using the priority queue on the basis of heap, but there will be TLE, okay, there will be TLE. So let's say, let's just assume just you're going to use the priority queue, okay. So sorry. So if you're going to use the priority queue, so let's say there are 2 1 3 5 and 6. So if all these elements are there in the priority queue, so basically when you're popping out, so the priority queue has to be like, it will be popping out the minimum element first, okay. So that is basically you have to use the min hip, okay, not max hip. Max hip is the by default thing, but you have to use min hip. So in min hip you can do what? You can just like, you will be taking this out and making this 2, then taking this out and making this 4, and just like whatever I did in this operation, okay. But if you go for that, as I have told you, you are going to get TLE. So you have to understand that you have a specific limit, okay, a specific limit till which you can use priority queue. So if the value of k is well before that limit, so it's okay, you can go for it, okay, otherwise you can't go for it. Now how you're going to determine that what is the minimum limit, okay. So it is difficult to determine what is the minimum limit of k such that I can go, like let's say I'm drawing this number line. So let's say there is a value which is the limit, okay, which is limit, and if your k is well before this, so it's well in the limit, okay, it's well in the limit. But if your value is greater than limit, so you're going to get a TLE. So yeah, so if it's lesser than limit, so it's okay. Now how we are going to determine what is the minimum limit that we have to use, okay. So we have to determine what is the minimum limit that we have to use for a specific problem. Now let's say I'm going to take the same example, okay, this example only. So let's say I have got 1. Now I'm going to use sort. We are just sorting it, okay. Now I guess you guys know like how you can sort it on the basis of the values and just keep the positions in place. I hope you know it. So we can just write 1 2 3 5 6, right? We have sorted it. Now what we can do is, you have to check like how many times do we need to multiply 1 with the multiplier m such that the element is just greater than 6. It's just greater than 6, okay. So we can see that if we multiply it 3 times, that is it becomes 1 into 2 2, 2 into 2 4, 4 into 2 8. So it is perfectly over there. So we can use a counter variable and we are going to store it. Okay. And what is the count variable? The count variable is going to tell us what is the limit that we can, it is going to tell us this limit. Okay, basically this limit. So basically over here, if we use 3, so we are going for it. Okay. For 2 to get after this, that is again, that is going to be 2, because 2 into 2 into 2, that is 8. For 3, if we go just into 2, it is greater than equal to 6. So we can go for 1. Okay. Oh, I made a mistake. Actually, I made a mistake. When I'm making it 2, so it's 3 plus 2. Okay. So that is 5. It was 5. And then 1, that is 6. Okay. And for 5, also 1. Okay. Because 5 into 2, that's 10. It's well above the limit. So we can see that 7 is the limit. So if we are having like a value of k lesser than equal to 7, so it's very easy, we can use a priority queue. As I've told you in the approach, you can use the priority queue. Okay, the mean hip thing. But what if it is greater than 7? Okay, so if it's greater than 7, what you can do is till 7 you can use the priority queue, and for the remaining portions we have to use a algorithm so that we can get like how many times we have to multiply them. Okay, so why is it so? Like, let me take the eraser once. Okay, so let me rub this out. Now see one thing. So after performing these 7 operations, okay, so what is like how the array will be looking like, or how the priority queue will be looking like? It will be looking like somewhat like this. Okay, 6, because 6 doesn't change. Okay, 6 and 6 over here. So basically this is the 6 that was initially over here. This is what 3 becomes after multiplying 1 with 2 ones. This is what 2 becomes after multiplying it with 2 twice, and this is what 1 becomes after multiplying it with 2 thrice. And this is 10, that is 5 into 2, that is after multiplying 5 with 2 just once. Okay, so this is what our new priority queue looks like. Now you can see one thing, that if it is as close as possible. Okay, now the whole thing, after we have done it till the limit, so it is as close as possible. So once we have encountered that it is as close as possible, so we know that if we are going to multiply this 6, if we are going to multiply it with 2, it is going to come over here. And after that, if we multiply this with 2, it is going to come after this. Okay, so there is a pattern that this is going to follow a circular pattern, right? So after this, the 6 comes after 10, this 6 comes after that 6, the 8 comes after this 6. So basically the order maintains but in a circular pattern. So using this, you can have a greedy approach and just multiply the first whatever the number of elements that you can get from the mathematical calculation. You have to find it and you have to just multiply those elements using that. Okay, so now I think it will be better if I can go directly to the code. Okay, so I will go into the code. The code, it is like, let me show you. So anyways, before starting the code, I'll tell you that this is not my code. This is a code that I found, and this is similar to that code shift logic. So I am too lethargic to code. Okay, so I just copied this code. So let's do the postmortem of this code. So what was the function? I think the function was final array state after key operations, right? Long expo. Okay, get final state. So you have got nums, k and mult. Okay. Now if mult is equal to 1, return nums. That is a very basic thing. That is a base case, because if you are multiplying any number with 1, so it doesn't matter, it remains the same. You can just return 1. This was not needed, man. This was not needed much actually. We can even comment this out. But for now, we are going to keep it. Okay. And this is the nums. Now see, what he has done is, he has, like as I was mentioning, that whenever you are going to sort an array, the position gets scattered out. Okay, but in order to keep the positions intact, we have to store the position along with the numbers. The numbers. Okay, so over here you can see that ARR of I of 0 is nums I, and ARR of I of 1 is I. Okay, so basically what he has done is he has stored the nums along with its position and then sorted the whole thing. Okay, clear? He's sorting the whole thing. Now he's taking the count. Okay, and for he's going from 0 to n, and he's taking like how many times he has to multiply it so that this is lesser than this. That is basically the last position where it is greater than. Okay, so let me write it. Last position that is greater than or equal to ARR of n minus 1, 0. Okay, so you're going to check that what is the last position that is greater than that. I mean the last, not last position actually, last value. Okay, what is the last value? That is the last value that is greater than or equal to that after multiplying with mul. Okay, with mul or mult, I don't remember what was it. It was mult. Okay, after multiplying with mult. Okay, so he is just multiplying it, and he is just storing the count. Okay, he is just storing the count and just multiplying it. So I hope this is clear. Is there any comments? Okay, no comments. छोटा मोटा यूट्यूबर हूँ भाई, कमेंट्स नहीं करता भाई. So anyways, so basically last value that is greater than or equal to this value. Okay, you have done it, and now he has divided it into two conditions. If k is lesser than or equal to count, you know that it is a very simple approach. You can just use priority queue for that. Okay, he's using the priority queue, and just he has given a comparator. Okay, as I was telling you, that is it has to be min heap, and since the multiplier thing is very huge and you have to find it till mod of 10 to the 9 plus 7, so he has given a comparator for both, like for all three of them. Okay, and he is adding the position with 0 and I. Okay, that is the position, I mean the number at the position and the position. He's storing both of them. So I hope this is clear, like what he has done. And then he's just simple thing, simple approach. While k minus minus, so he is going to take out the first element that is going to be out and just make the thing, that is he is going to multiply it. Okay, since he is using this multiplier thing, so he has done this current one, this logic. But I think this was not needed much, so you can just go with simple approaches also, it doesn't matter. Okay, so what he does is he is going to make while not pq is empty. And okay, so he over here he is just storing the thing. Okay, so he is just making the plus plus. Okay, so I thought that this was the main thing, main code. Okay, so this is not the main code. So over here he is doing is what, while not pq dot empty, so he is going to multiply it with that exponential thing with mod. Okay, so this expo thing is basically the code that is at the end. Okay, I hope this, I think this is not visible actually. I'll share the code. Okay, I'll share the code. So okay, let me like give some spaces behind this. So now I think this is visible. Okay, so this is what the exponential thing means. He's just making it mod. Okay, making it mod. And the comparator, as I have told you, that thing is the comparator, so mean hip and basics of that. Okay, and so while k lesser than equal to, I mean sorry, not while, if k is lesser than equal to count, so this is the case, this is case 1. Okay, this is case 1 and this is case 2, this is case 2. Okay, so what basically happens in case 1, you know what happens in case 2, you are going to use the same thing, and till count it is going to have the same thing. And after he has performed all the operations till count, after that he's sorting the array now. Okay, after that he's sorting the array so that it becomes easier for him. And this is the basic calculation, as I've told you, that k by n, because like if you're having n, okay, so let me like show you why the calculation is like this. So if n is over here, okay, so how many times all elements should be multiplied? It will be k by n, right? And how many elements before should be multiplied more than that k by n is going to be k mod n. like I'll explain it why. Okay, so I hope he has used k-mod n also. Yeah, k-mod n. Okay, so basically he has made all is equal to k by n and left is equal to k mod n, and then he has multiplied all with k by n and left with one more. That is the thing. Okay, so basically you can see that he has multiplied it with all. Okay, all for every element, and if it is belonging to the left, lesser than left, that is anything before the left, so he has multiplied it again. So why is it so? I'll explain it, and he has just returned the answer. Okay, so this is simple. This is simple. This part is simple. I hope this is clear. So I'll just explain you why. So let's say you have something of size n. Okay, something of size n. Now, and you have to like put elements, k elements in this order. So one element over here, then the next element over here. Since I have told you that it is going to perform a circular pattern. Okay, so basically what he is doing is he is just going to calculate how many times the first element, or how many times every element of the whole array is going to get operated, that is, it is going to get multiplied. Okay, so you can see one thing, that k by n plus k mod n. Okay, this k by n plus this k mod n, if you add both of them, it becomes k, right? So basically, since it is circular, he is just going for k by n for all the elements. For all the elements from 0 to n minus 1, he has to make it k by n. He has to multiply it with multiplier k by n times. And for the remaining k mod n, okay, like after using k by n times, so you can say one thing, that if you use k by n times. Okay, after you use k by n times, that is, you're dividing this k by n operations throughout the whole array. So you are left with k, right? You're left with k. That is what our mathematics tells us. But this is not true, because k by n is an integer. Okay, so what he is doing is k by n plus k mod n. Okay, he is just adding k mod n to the first elements, to the first k mod n elements. That is, to the first k mod n elements, he is just multiplying it with that multiplier once more. I think I'll explain it using this example 6, 6, 8, 8, 10. So let me write it. Let me do one thing. Let me delete the whole thing. Okay, make it fresh. So let's say you have got 6, 6, 8, 8, 10. Okay, let me write it like this. 8 and 10. So how many elements are here? 1, 2, 3, 4, 5, right? So let's say we had the value of k was somewhat 12. Okay, clear? So the value of k was 12. So what you are going to do is 1, 2, 3, 4, 5. Then again come to this 6, 7, 8, 9, 10. Again come to here 11, 12, right? So you can see one thing that is very interesting, that is, if we make k by n, that is k by 5, n is over here 5, right? We are going to have k by 5 and k mod 5. Okay, we are also going to have k mod 5. So k by 5 is basically 2. 12 by 5 is 2. And k mod 5 is also 2. Okay. So see one thing, that for all the elements, there are minimum 2. Okay, there are minimum 2. So they are multiplied twice. But for the first 2 elements, they are again multiplied once. Okay, for the first 2 elements only. So I hope this is clear. This is the logic behind this. So if you have any problem, I think I got very less viewers, I guess. Huh? I think I got very less viewers. Are there anyone viewing it right now? Okay, it's 2 watching, among which 1 is me. So whoever is the second person, just comment. Okay, just give a like, just write it on the comment section that yeah, I get it, something like this. Okay. Okay, so I'm audible, I guess. Yeah. So I'm audible. So I'll just request you that whoever is watching this, just okay, now it's for watching now. Okay, so it's for watching. So just write in the comment section that you are watching this video. Okay, so that I get the confirmation, I guess. Or am I lagging? Okay, I think, am I lagging? Like, anyhow, I don't know. Okay, so anyways, leave it. So we are going to go to the next problem. Okay, sorry. Okay, now we are going to go to the next problem. I hope this is clear for everyone, right? I hope this is clear. If it's not, I'll just request you to to just write in the comment section if it's not. It's for watching, man. It's for watching, and one is me, I guess. I don't know how the views are calculated actually. So if it's for watching, just write it on the comment section, man. That yeah, I get it. So that I can go to the next video. So it's basically 11:18 now. I'll wait till 11:19. So if I receive any comments, that's good. If I don't, I will be. Hey man, hey, sup? How you doing? Did you watch the whole explanation of the A video that I gave? Just give a thumbs up, okay? Or just say that yeah, I got it. Hey. So it's 11:19. So I think I should. Okay, you just came now. It's okay. It's okay. You can like watch the previous part of the video later on. So I will be explaining the second part. So okay, just whoever it's Vivo Sharma. Okay, so did you get, like, how many questions did you get right in today's contest? Okay, chat. I'll be starting the remaining part of the video after this. Okay, I will starting the remaining part of the video at 11:20. That is next. That is the second and the third question. Second and the fourth question, I mean. Okay, so Vivo, I think I'm lagging. Okay, I did first and second. Okay, that's good. So now I'll be explaining the fourth question. Okay, Vivo. So the fourth question. So basically, okay. So I think So this is what the code looks like, and for the first also you can go for this type of code. Okay, I think there's no difference in the first and the last question, so it's basically the same thing. So you can go for the same code for both the questions, but it was an easier thing. So you could have gone for like normal brute force. It also works. Okay, if you want, I have the normal brute force also. Okay, so I have normal brute force also. So the normal brute force looks very simple. I'm just giving you the thing so that you get it. So it was very simple. It is like you traverse throughout the whole array. You perform key operations, and throughout the whole array you find the minimum element and just multiply it. So that is very simple. Okay, so I won't explain this. Clear? So let's go for the fourth and the second problem, which is basically, the fourth problem was basically a harder version of that. So want to solve third onwards. Yeah, I'm actually, I did what, okay, Vivo, I did what is I solved the first and the third problem because they were the same thing. Rather, I'll say that third problem was a little bit advanced version of the first problem. So what I did was I solved the third problem, and I just told that you can solve the first problem based on that thing also, and you can also use a brute force. So it doesn't matter. You can do whatever you want to do. And now I'm going to go for the fourth problem. Okay. So this is the fourth problem. So count almost equal pairs 2. Okay, so you're given an array nums. Okay, in this version, the number of that can be performed has been increased to twice. So this is what basically it is saying that. Okay, 1 minute. I think I'm having an issue on the microphone. So let me just fix it. So yeah. Now I'm going to be audible. So actually what I was facing is that I was connected to a Bluetooth device, so it was lagging a little bit. Okay, from my end. I don't know from your end whether it's okay or not. Okay, so let's get into the video. Um, so previously in the first on the second question, the operation that can be performed was once. Okay, was at most once, but over here it is increased to twice, which is not much of a difference. So let me just go for the question first. You're given an array nums consisting of positive integers, and we call two integers x and y almost equal if both the integers, okay, if both the integers can become equal after performing operations at most twice, not once. Okay, so what you have to do is choose either x or y. That is, if you're having two integers x and y, so you can choose either of them, and you can swap the position of at most four things. Okay, at most four things. Why so? Because if you're swapping the first and the second thing, so that is one swap, and if you're swapping the third and the fourth thing, that is two swaps. Okay, and you have to find how many pairs are possible for that, which is very like, okay. So let me go for the solution. Okay, so let's say, okay, is there any comments that I need to look for? Yeah, okay, no comments. So yeah, let's get into the solution. So what we're going to do is like, let's like the simple approach is okay. You have to find for every pairs. Control A, delete. So you have to find for every pairs, that is I, comma j. So just you can traverse for I and j. That is, I is going to be from 0 to n. Okay, from 0 to n, that is I lesser than n. Okay, and j can be from I plus 1 to n. Okay, so this is what j is. So you can find all the pairs based on that, and you have to like just check for nums of I and nums of j, right? Like whether it is going to have a valid check or not, and if it's going to have a valid check, you can make answer plus plus. Okay, clear? This part is I think this part is clear, because this was a very basic thing, and this occurred in, like, if you have solved the second problem, so you have got this thing that it is this simple. Now, okay, so I was making two frequency maps for checking frequency of each digit of both nums and making sure that both are equal and the number converted to the string differs at 4 indices. Or see, it's not like 3 is not going to work. Okay, 3 can work. So I'll just tell you why 3 is going to work. So let's say you have 1, 2 and 3 at 3 positions. I'm just taking the positions where they differ. And over here it was 2, 3 and 1. So what you can do is, basically, if you're performing a swap for 1 and 3, so it becomes 3, 2, 1. And after that, if you swap this 3 and 2, it becomes this, right? Right, Vivo? Do you get it? Just tell me if I'm pronouncing your name wrong. Okay, just tell me. So do you get it? Like, why is it so? You can have for 3. Okay, you can have for 3. Okay, so let's get into the thing. Okay, let's get into the video. So you're going to check for nums I and nums j and answer plus plus. Okay, so 3, 2. Okay, so this was what I was explaining to him. So I'm going to just cancel this out for now. So this is the basic thing. So this is a basic thing, and this I think most of you have gone for. Now, as Vivo was telling that you have to find how many positions they are going to differ. But before that, it was given in the question. So if you go to the question again, this was the question. Yeah, if you go to the question again, you can see that we can have trailing zeros. Okay, it is allowed for an integer. Sorry, not trailing. Sorry, we can have leading zeros. Okay, so it is allowed for an integer to have leading zeros after performing an operation. Okay, so you can have some leading zeros. So in order to check this, what you can do is, so let's say whenever we are going to check, okay, so I think it will be better if I just delete the whole thing right now and just go for the check thing. Okay, so if you're going for the check thing, okay, let's say you have got A and B. I don't remember what was the variable that I used in the code. So anyways, let's say you have got check A and B. Now, okay, just let me see like what was the variable that I used. I think I used A and B only. Okay, I used A and B, so that doesn't matter. So if you're going to use, if you're going to check A and B, so what you can do is, let's say the length of A is lesser than B. So you have to add some trailing zeros to A. Okay, you have to add some zeros to A, and you have to perform this while the length of A, okay, it is lesser than B. This is always length. Okay, this is always length when I'm mentioning this. So while this is lesser than B, you have to add some zeros to A and vice versa. Okay, so even when B is lesser than A, you can add some zeros to, you can add some zeros to B also. Okay, so after doing this add things, so now you can say that all the elements, okay, all the elements, like, I mean not all the elements, I mean both the elements, that is both the numbers. So remember one thing, okay, I think I forgot to tell you that whenever you're going to check for the check thing, so you have to convert the nums to string. Okay, you have to convert the nums to string, and you can add some leading zeros to A or B based on. So what you have to do is basically you have to make the whole thing, the I mean the length of A and B equal by adding some zeros to A, to adding some leading zeros to A or B. Okay, clear? Now comes the main check thing, how you're going to check for it. So what you can do is, you can basically go for all the, okay, so let me check the comments. Is there any comments? Kind of got it. Okay, yeah, I think that you were like confused with the 3 thing, so I think you messed it up. So anyways, so if you're like, so after that, what you're going to do is, you're going to find out what are the different what are the different positions. Okay, what are the different positions where the A of I, okay, where A of I and B of I differs. So if you get the positions where A of I and B of I differs, so you can come up with a thing that is, for that specific position you have to use a swap. Okay, and for the remaining positions it's okay, you don't have to use the swaps. So now, based on the value of the positions, okay, the number of positions, okay, so whenever it is not equal to this, so what you can do is, you can have the places where A differs, okay, the places where A differs and the places where B differs, and you can name it AD and BD respectively, and for every time you're going to make difference plus plus. Okay, and before making this, AD of difference is going to be AD of difference, it is going to be that position, and similarly BD of difference it is going to be I. Okay, or not I rather, you can make it nums of I. Not nums actually, sorry. You can make it a of I. Okay? A of I. And this is going to be b of I. Okay. So you have got all the positions where they differ, and you have like stored the characters of the positions that they differ in an array called AD and BD, where AD is where A differs and BD is where B differs. Now, there are 4 conditions that we have to take into consideration. That is, you can either have differ as 1, 2, 3, 4, and anything after 4 we have to eliminate it, because if any number, if the number of differences is greater than 4, so you will be needing more than 2 swaps, right? So you can eliminate them. But if there is only one position where we need the difference is occurring, so it means that no matter how many swaps you are going to perform, because on one swap you're just going to swap 2 elements and just make both the elements differ. Okay, so it is not possible to have one, because that means that the frequency of all the things on A and the frequency of all the numbers on B are not same. Okay, bro, you please improve handwriting. Okay, actually I think I'll tell you this. Okay, so I was using that handwriting thing. I used to post videos like on by making it on paper, but I feel like it's better to do it on screen. Okay, so I'm just trying. Okay, so I'm just having a PC at this moment. Like, if I think it would be better if I had a notepad or pad, something like that. Okay, but right now I just have a PC, so just bear with me. Okay, bro, you placed nope. CP से घर नहीं चलता भाई. So anyways, let's get into this. 1, okay, so for 1 you can ignore it, and for 4 also you can, so for anything greater than 4 you can ignore it. Okay, now for 2 and 3, okay, so remember one thing, whenever you are going to have the 2, that means you have to perform only one swap, and for 3 you need to perform 2 swaps, and for 4 also you need to perform 2 swaps. Now 4 is a little bit difficult. You can say that 4 is a little bit difficult because the number of permutation and combinations for 4 is more. For 3 it is lesser than 4, and for 2 it is lesser than 3. But whenever you're going for 2 or 3, so let's say you are having X and Y, okay, as AD, where A differs. For AD it is my handwriting sucks, I know, you don't have to tell me. So for AD and for BD, okay, and for BD, let's say it was Y comma X. So in that case we can say that if we swap these 2 positions, so it is perfectly valid, right? Wait, I'm the guy who leaks solutions to problem during contest. I guess now you don't do it. Okay, I think I should release a diss track on you. Okay, I'll release a diss track on you. So anyways, yeah, I used to like, I didn't leak solutions. I'll tell you that I was just explaining the solutions while in contest. So at this moment I'm not doing it. Like I'll this is a thing. Okay, so I got plagued on one contest because I don't know how, like I don't know, even like they didn't even give me a mail like whether I got plagued because there was solution similarity with someone or not. So they just gave me a flag on a Code Forces contest. So after that I stopped doing it. So now I'm just uploading videos like after the contest is over. Okay, so Aman, now that's a serious allegation. See, the thing is that I'll tell you that if I'm just giving you the solutions, okay, if I'm just giving you the solutions, I'm not giving you the codes, okay, I'm just telling you like you have to do this and this. I'm not even giving you the implementation of the whole codes. So at that moment I used to think that was not cheating, but Actually, you know what? Most of the people most of the people who have subscribed to me, they are like, okay, but explaining during contest is also bad. Happy to see. Yeah, now I don't do that. So basically, what happens is like during the contest, some people are like they need the code. Okay, so what I basically tell is that whenever if you're sitting for examinations, so you can see that whenever sitting for examinations, there are like two different kinds of cheaters. Okay, one cheater who takes a cheat paper in their pocket and they just write it, just keeping it like keeping their hand over it and they just write it. And there's another kind of cheater who goes to the washroom and just opens the cheat paper and just memorizes the whole thing or just understands the whole thing and then just keep it there in the washroom and just come back and just write it. So I was doing the second type of cheating. Okay, so I hope this is clear. So anyways, leave it. So that's not related to a problem. So that's just let me go for the thing. Okay, so basically you're having xy and yx. So let's say you can swap these positions, so it works. Okay, if you're going to swap these positions, it works perfectly. Now let's say you are going to have xyz, that is xy. I think my PC is lagging a lot. So xyz. Now in whatever manner this xyz occurs over here, it doesn't matter. Since you can have maximum 2 swaps, you can rearrange the whole sequence of xyz. Okay, you can you can check for all the permutations of xyz and you can just swap twice and like you can get that permutation, right? So if it is so we can say one thing: it is better like to sort AD and to sort BD. Okay, and just check if both of them are equal or not, because we can get any permutation of xyz. So the most greedy approach is going to be sorted and just check whether it is going to be a good thing or not. Okay, like it's possible or not. So for 2 and 3, okay, so let me like erase this. I erased the wrong thing. Oops. Let me erase this, only this portion, okay, because we are not going to need this portion anymore. So whenever you're getting like xyz as such, so it is clear that for 1 it is impossible. For anything greater than 4, it is also impossible. For 2 and 3, we can simply sort them and check if it is possible or not. Now comes the main condition, that is 4. Okay, now comes the main condition, that is 4. Now for 4, we could have also gone for the sort thing, right? We could have also gone for the sort thing, but there is something which you have to understand. That is, only if there are 2 positions where if we swap them, then only you can like it can happen. So let me give you a problem where this thing will work, but it is not possible to have the swap. Like the sorting algorithm will work. So 1, 2, 3, 4, right? Sorry. 3, 1, 2, 4. Now, no matter, however, sorry, not 3, 1, 2, 4, because in that case it is going to differ by 3, right? So let's say 3, 1, 4, 2. Okay, so now over here, if you are going to swap with 4 and you have to put it over here, so this becomes 3 and this becomes 4, and you are left with 1 swap only. So which is like you are not going to get the actual answer over there. And if you sorted 1, 2, 3, 4 and 1, 2, 3, 4, this satisfies. But actually this is the wrong answer. So what you can do is you can use a normal brute force thing. Okay, so let me keep it over here. So what you can do is, for every element you're going to choose any 2 elements from here. Okay, so that is I comma j. You're going to choose I comma j and check if swapping those 2 elements are going to give you the perfect position for those 2 elements or not. So let's say where the first thing differs is 1 and where the second thing differs is 2, right? Now if we swap them 1 and 2, so that becomes 2 comma 1, right? So that is 2, sorry. Uh, I didn't mean it like this. So you have to find where 1 occurs, so that is this position, and wherever the next position occurs, so that is this position, right? So you can swap. So this is the position where the swapping has to occur. Okay. So if you are going to swap these two elements, so it becomes 2, 1 now. Remember, this occurs only for 4. Okay. For 2 and 3, I have explained it earlier. So now it becomes 2, 1, but 3 and 2 are not equal, so you can't go for it. But on the same hand, if in spite of this 3, okay, in spite of this 3, there was 2. Okay, there was 2, and the 3 was over here. So you can notice one thing, that it was a valid thing. Okay, so because you can swap these two elements and these two elements. So in that case, the sorting will work, but otherwise the sorting won't work. So what you have to do is, you have to find the position of the first element, and you have to find the first position where in the BD where that element is present, and you have to swap them, so that basically you are going to make the position of the first element perfect. Okay, but by doing that, if the element that you are swapping with, if the position of that element doesn't get perfect, so you can understand that it is not possible. Otherwise it is possible. So I think this is clear. Brisbane Union Contest is bad. So just give me a thumbs up if you like. I don't know how many people are over there in my live. Okay, just 1. So I think okay, it's just me. Okay, so no one else is watching. So I'll just go to the code. I'll just go to the code and just explain you. So what I have done. So basically, this is the normal thing that I have told you, that for I 0 to less than n and j less than n, from I plus 1 to this. So you're going to check for all the pairs, and if the pair exists, you're going to add 1. If it's not existing, so you have to add 0. So that is the result. And for everything almost equal or whatever, I named it check, I guess. Okay, in the question, in the explanation that I was explaining, I named it check. Okay, so for that check thing, what you can do is, first of all, you have to like add some zeros to it. Okay, over here he has not added any zeros because he knows that whatever, it doesn't matter. So he has added, I think he has added zeros beforehand, but you have to add zeros. Okay, you shouldn't forget that you have to add some zeros. So what you can do is, you can check the elements where it is differing. Okay, so whenever you find a differing element, so you have to make it AD found, found plus plus. Over here, found is actually diff. Okay, found is diff. Now, if found is equal to 4, you have to break. Why is it so? Because I have told you that if anything is greater than 4, so it makes it valid. Okay. So if found is lesser than equal to 0, doesn't matter if return this found equal to 0. Okay. Because basically, if found is equal to 0, it means that both the A and B are same. Okay. So you can just return true, and it is found is equal to 1. So you can basically replace it like this. So if found is equal to 1, you can return false, and if found is equal to 0, you can return true. Clear? So you can even do this. So after this, you have to go for 2 and 3. So for 2 and 3, as I have told you, that you have to sort and check if both the arrays are equal or not. Okay. And for 4, you need to get a matching pair first with the same indices, then all the digits should be matched. Okay. So like, let me go somewhere over here. So if found is equal to 2, so this is done. And if for I is equal to 0 to 3 and for I plus 1 to 4, so you are going to find a perfect pair where swapping them makes it a perfect thing. Okay, where swapping them makes it a perfect thing. So basically, if you're swapping I and J positions, so that thing is valid, that swap is valid, and then you have to check for the remaining sorts, and then you have to sort it and just check for the equal to thing. So that I've explained in the code. Okay, so basically if you submit this, I hope this is going to get accepted. Okay, so this gets accepted. Okay, and for this, okay, is there anything that I need to? Hitesh, bro, show the code of question 2 brute force, please. Okay, you want to check for the question 2 brute force. Okay, I have the code. Doesn't matter. I have the code. I'll show it. I'll show it to you. So I'm just first I'll just submit the codes for these operations. Okay, for these C and D. Okay, then I'll show you the code for B. So for this B, so it gets accepted. I mean for C it gets accepted, as I was explaining in the previous thing. And for this B, I'll show Hitesh the code. And for this, you know that this will get accepted also. Okay, this gets accepted. So I'm just removing this. And for this will get accepted. And remember one thing, whenever you're going to do for B, like if you're going for the thing that I have already mentioned, the logic. So for B, you know that the minimum number of the maximum number of swaps is 1, right? So the found has to be 1, 0 or 2. For 3, you can't go for it. Okay, like let's say for 3, if there are 3 positions where it differs, it won't satisfy, because I have explained in this thing that it is only going to satisfy when 2 positions differ or something lesser than that. Okay, so for 2 position for 1 position, the same thing that is found equal to 0, you can go for return true, and if it is equal to 1, return false, and if it's equal to 2, just sort it and just return it. Okay, so this is Hitesh, I think this is also the brute force approach, dude. Yeah, I'll show it to you. It doesn't, like, you don't have to plead like that. So Hitesh, I think this is a brute force also. Okay, this is also brute force, but I hope you whatever, like, what do you mean by brute force? I think I get it. Okay, so this is also brute force, where that you have to check for every positions where this is differing. Okay, but if you want other solutions, like other, I think by brute force you mean this. Okay, so it shows me only for the weekly contesting. Okay. No problem. I'll just go for my solutions for that. No, it doesn't show me for that. You want it for B, right, Hitesh? This is actually my second account. I don't know whether this will be present over here or not. It is submitted using this. Okay, so B, yeah, Hitesh, I think I got it. I think you're talking about this thing. Okay, Hitesh. I think whatever you wanted was this. Okay, Hitesh. So basically what this brute force is, that I'm just checking for everything, for every pair, and if the numbers are equal, you can go for count plus plus, and if it's not equal, so you can go for checking them, and for every checking you have to add some leading zeros to first or second based on, so first is num1 and second is num2, so you have to add some zeros based on the fact that you have to make both first and second of same length. And for differ, so this is a difference thing, and A is equal to -1, B is equal to -1. Okay, so that is the positions where they are going to occur, the positions, the 2 positions where they differ. So you can traverse through the whole thing and check if first and second doesn't match at that position. So you can make difference plus plus, and if difference is equal to I, A is equal to I, B is equal to I, and if difference is equal to 2, so B is equal to I. Otherwise you can return false. Even just, you can ignore this also. Okay, you can ignore this, it doesn't matter. So if difference is equal to 2, because if difference is equal to 0, it's okay, it is satisfying, and if difference is equal to 0, this is the situation. Okay, So that is the reason I just wrote for the B, I just wrote it directly so that I don't have to check for difference equal to 0 in this check thing. And if difference is equal to 1, you know it's going to be false, because one position can't differ. If we have to swap, a swap actually changes the position of two elements together. And if difference equal to 2, you have to just swap first A and first B and check if first and second is equal. So if it's equal, you can return true. If it's not equal, you can return false. So is it clear, Hitesh? Are you watching, Hitesh? Like, just tell me if you're watching it, okay? Otherwise, I'll be ending this video. Hitesh, if you're watching, just respond. It's 11:53. I'll end it on 11:55. Okay. I don't even know whether Hitesh is watching or not. So I'm just assuming that you're not watching this video. Okay, I'm just assuming that you're not watching this. So if you're watching this, it doesn't matter. Like, you can check the whole thing. Okay, you can check the video later on. So I hope that is clear. So that's it for now. So I'll be ending this video. So just let me see the size of this. So that's it from my side. So I hope the questions that I have explained, it was clear very much. So that's it from my side. So I'll be ending this video. So if you have any doubt regarding this whole solution thing, I'll pin the Discord and the Instagram link on my description, or even on my, I think I'll pin it either on the description or on the comment section. I'll pin it. So you can join that server, or even you can text me on Instagram. So I'll just explain you like how to code these things, and the codes it will be available. I think I will be uploading the link for the submissions. I'll try to like do that. Okay. So that's it from my side. So that's it. Thank you.